think I'm back. All right. This should be working now. I see that it's picking up audio. Take 3. If you didn't see take 1 and 2, that's all right. So this is day 2 of me trying to teach myself linear algebra with nothing but ChatGPT, some clever prompts, and some willpower, because it's been 15 years since I took a formal math class. Never got to the linear algebra level. Always thought it seemed kind of neat. It seems like the prerequisite for a lot of things in machine learning and physics and other things. It's sort of the last on the ladder of essential math classes to understand the sciences and things. I'm sure some actual mathematician will dispute that, but the point is, I think that ChatGPT is amazing to teach stuff and to learn things from, and it can be the ultimate tutor. I'm going to see how far we can take that right here. So, without further ado, I want to start by recapping what we did last lesson. You'll see the layout's a little bit better now. I'm learning how OBS works as we go, but I have my iPad screen here, which is through QuickTime. I'm using Notability now, which I think is a much more smooth experience taking notes, solving problems. I have ChatGPT window right here with my same chat of this accelerated linear algebra course, learning it at an elite Ivy League MIT level. And what I'm going to start by doing is reviewing a couple problems from the last lesson that I didn't have the time to get to. I asked for challenge problems because I found the initial problems a little bit basic, a little bit rudimentary, and things that I honestly didn't have to stretch that far to be able to do. It didn't feel like, from my experience at an elite college, what they would ask of their top math students. But these problems are actually pretty darn good, and that's been an interesting thing I've noticed about the new GPT models, is if you just ask it for harder problems with a couple twists that would challenge students, it does a pretty good job. So let's look at the second problem. They want it to this is more of a theoretical thing, construct a 3x3 system with infinitely many solutions, but no 0 rows. So infinitely many solutions, if I'm remembering correctly, is when you convert to row echelon form and the bottom row is 0, 0, 0, 0. So that's right. For no 0 rows, we want to avoid a row like that, is what it's saying. So bonus, full row rank, but not full column rank. So there are a lot of key terms that they bold that are kind of tricky, and I'm going to be writing down the key terms as we go as well, just in drafts right here. This is my go-to note-taking thing. So I'm going to go linearly independent, rows linearly independent. What does that mean? Columns dependent. All right, we'll see what that means. So here's an example. They give us x plus y plus z equals 3, 2x plus 2y plus 2z equals 6. So we see these are essentially the same equation repeated twice. And x minus y plus 0z equals 0. All right, so if I row reduce, I get that last row, 3, to become 0, -2, -1, -3. Reorder the rows to get rid of the 0 row in the middle. So there's a 0 row in the middle is the issue here, it would appear. Okay, so I'll be honest, I don't understand this problem right now. I'll have to review this one more, but I'm going to just skim through the rest of these. So I'm just note star here. Problem 2. In solutions. All right. And these are, just so I know, day 2. Call this LA notes. All right, starting that problem so I can review it later. I'm trying not to do homework in this class. I'm just spending an hour a day for 30 days to see how far I can get with my linear algebra knowledge. I'm trying not to do homework. I may build an app or something just to quiz myself on vocabulary and some of the key concepts that at first were a little shaky. Just some passive thing that sends me an email every so often or a notification in my browser. That's a tool I'll build another day though. So the max number of solutions for a 3x2 system. So the system can have 0 solutions, not in the column space of A, 1 solution, consistent system with rank equals 2, no free variables, infinitely many solutions. All right, so for a 3x2 system, it can't have exactly 2 solutions. It has to have 1, 0, or infinitely many solutions. That makes sense. Basically, lines can only cross, in one way. If it's 3x2, a lot of this terminology, though, kind of tricky. So if I were taking this and taking my time more rather than just reviewing last lesson before I jump into this, we'll see if I have time at the end. I'm devoted to spending about an hour. First lesson was about 40 minutes, but I'd have to ask a lot of follow-up questions here. All these bolded terms, a lot of stuff that I don't fully understand. Maybe I should take note of those right now. So what's the column space? B not in the column space of A. That's something I need to know. So I'm going to write column space here. Oh, is my pencil working? Yeah, column space. Okay. And then let's get this back on top. What else was confusing? Rank equals 2. So those are the things that I want to review later. Structure of homogeneous solutions. This is another key term I don't really know. Homogeneous solutions. And I'm okay with not knowing this stuff as long as I take note of it. I can come back later. I want to have just a vague idea. This is skimming, which is always a nice thing to do before you dive into the deep thinking to understand a concept. Skim it, give your brain some time to digest it, and then really go in. So to be a subspace, something has to contain the 0 vector, be closed under addition, be closed under scalar multiplication. All right, so there's a lot of variables and terminology here that I'm not super familiar with. Let's see. A such that the set of m times n, all real numbers, m times n. I feel like these problems are probably more advanced than what I'm supposed to know, but I'm going to just write this down again. Rank nullity theorem. The first practice problem was a good stretch using algebra skills with what they taught in the first lesson. This is clearly some new stuff. So the rank of A plus the nullity of A equals n. No idea what's going on. I don't know what dim means. I'm going to write some of these things down. Dim, null, and rank. So clearly there's some terminology for matrices and linear algebra that I'm missing. It can be done though. It shouldn't take too long. All right, now I have this infinite system, an infinite chain of equations, each involving 2 neighboring variables. So for this one, can it have a solution? Yes, and it can have infinitely many solutions. Here's the example. Pick a value for a variable, say x of 1, and the rest are determined recursively. Well, it makes sense. I know recursively means they're determined based on what a previous one is. So if I say x of 1 equals 1, then x of 2 equals 0, x of 3 equals 1, and they'll alternate between 0 and 1, or x of 1 and 1 minus x of 1 as a general formula. That's a clever way of solving it. You start with this one, you do substitution, and prove that x of 2 and x of 3 and x of 1 are equal to each other. So it's like this: if n is odd, if n is even. In its behavior as it approaches infinity, is it oscillates forever between a and 1 minus a. So that makes sense to me. It's not going to converge on a specific value. It's just going to oscillate forever. All right, cool. I'm ready for lesson 2. That was our little warm-up with stuff that was honestly way too advanced, but that's all right. So I'm going to go way back up to the lesson plan that I had ChatGPT generate for me. And we're going to lesson 2. I just want to copy it so that it remembers this. Lesson 2, give me a hour's worth of material and problems for this content you mentioned earlier. All right. Sip the coffee while I wait for it to load. So perform Gaussian elimination to reach row echelon form. Familiar with that? Row echelon form is where the bottom left corner of the matrix is converted to have all zeros so that you can then solve for z, y, x, or whichever variables you have. Identify pivot positions. That was something I struggled a little bit with last time. Gonna have to make sure I define that and use them to compute rank. Understand the difference between row echelon form and reduced row echelon form. Okay. And then use back substitution to solve from row echelon form. I'm familiar with that. You get it so that that bottom row gives you one variable, and then you just keep going row by row until you have all the variables. So this looks kind of crazy. Start recognizing when a matrix is telling you deep structural info about the system it represents. Interesting. So deep structural info, I have no idea what that means. This sounds like some literal matrix level stuff. So read through the conceptual notes, work through the guided examples, try the practice problems, take the mini quiz. Let's go. Core concepts. Gaussian elimination. This is just using algebra, essentially, combining equations to reduce one of the rows to zeros, similar to elimination when you solve systems of equations in Algebra 1. A matrix is in row echelon form if all non-zero rows are above any rows of all zeros. It's such a weird way of phrasing it. You should give examples. Like in your notes, always give examples to explain concepts. You can see it in action rather than just reading a description. I know what row echelon form is, but I would not understand it if I hadn't had some knowledge from taking Algebra 2 classes and tutoring, that kind of stuff. Okay, so yeah, the pivot point is when you're going from left to right, it's the point where the first non-zero number is. Reduced row echelon form is where each pivot is 1. Each pivot is the only non-zero entry in its column. This is the form you get from Gauss-Jordan elimination. I recall this, I think, too. I might want to do some practice with that, though, to review. This is something that's taught in some advanced Algebra 2 classes, pre-calc classes. So pivot is the first non-zero entry in a row, working left to right. Yep, remember that. Number of pivots equals the rank of the matrix. Oh, cool. Rank tells you how many linearly independent equations you have, and then how many variables are constrained versus free. So that's another key term I'm going to write. Constrained versus free variables. All right. Back substitution. Once you're in row echelon form, you can solve the system by working bottom up. So this is row echelon form because we have the zeros in the bottom left corner. It's nice that we have ones going across here. And then you know that z has to equal 2. 1z equals 2. Then you go 1y plus 4z equals 6. So you can use that to solve for y. And then finally, you can solve for x. You got all that right here. Solve this system using Gaussian elimination. All right, time to do an example 1. Let's go down. Okay, example 1. So we have, I'm just going to write the matrix down. I have 1, 2, 1, 7. I have 2, 3, 3, 15. And I have 1, 1, 1, 8. All right, cool. So I first want to get this bottom left 0 to be, bottom left digit in the matrix to be 0. So what I'm going to do is adjust my microphone a little. I'm going to go row 3 minus row 1. Let's hope that doesn't mess stuff up. And then that row is going to be, just write it here, Still have 1, 2, 1. Don't have to change anything in that first row. Still have, I might as well do another one as well here. So row 3 minus row 1 is here. This is going to be 0, -1, 0. And then row 3 minus row 1 is going to be 1. And then this second row, I'm going to want to get this 2 to become a 0. So I'm going to be doing R2 minus 2, R1. So that becomes 0. 3 minus 4 is -1. 3 minus 2 is 1. And 15 minus 14 is 1. All right. So this is pretty close to being done here, I believe. I'm going to scroll down and maybe switch this around slightly. I'll make it so that I'm going to speed this up here. This goes right here. My notes are messy. I'm going to get better at writing notes down as this goes down. Apologies. So first row stays 1, 2, 1. And then the augmented matrix has 7. Second row and third row, I'm actually going to switch those around. I think that might be helpful. So this is 0. I'm actually going to just multiply this whole thing by -1, which you can do. 1, 0. This was the third row. Now it's the second row because I would like having this go across. 0, 1, 0. And then it's going to be -1. And from that, I already know that y equals -1. And finally, I have 0, -1, 1. I want to make this into, what I'm going to do for this last row, though, is go row 3 plus row 2. Messy again, but what that will make this last row become is, can't be that messy here, 1, 2, 1, 7, 0, 1, 0, -1. It'd be helpful to have someone who's really neat, someone good at writing math to help me with my notation, like little notation coach, because I don't feel like my notes are that nice right now. And then last one is 0 plus 0 is, probability. 0. I add row 3 plus row 2, and I get 0, and I get 1, and then I get, this was 1 right here, 0. All right, so I get, from this, I get z equals 0, y equals -1, and then x plus 2y plus z equals 7. So therefore, x equals, x plus -2 is 7, so x equals 9. So therefore, the solution to this is 9, -1, 0. Let's go check my work. Oh, I got a couple examples here. First, give me solutions, just the answers, for examples 1 through 3 from your last message. All right, time for example 2. Example 2. Find the rank of this matrix. So the rank of this matrix, I think, is rank 1 because, no, is it rank 3? Because it has, I thought it was rank 1 just because of that third row, but maybe all 3 rows count. Count the pivot positions, reduce to row echelon form. But I can do that. It's reduced in row echelon form. I should get a lot quicker with as I practice. So 1, 2, 3, 2, 4, 6, 0, 1, 1. So what I'm going to do is first get, I'll do the second row first. So I'm going to go, let me give myself a little more space on the left and right side here. So 1, 2, 3. There's no augmented matrix here, makes it maybe a little simpler. And so I'm going to go row 1, R2 minus 2R1 is going to give me 0, 0, 0. Oh, so I get a 0, 0, 0 row here. And then for the last row, I want to get it to be 2 zeros to begin, not just 1. And so I'm going to go 2R3 minus R. Oh, that's not going to work, because I'll get rid of that leading 0 then. R3 minus R1 over 2. Yeah, that's not going to work either, is it? How can I do this? I want to keep that as 0. I mean, just as an example, if I did R3 minus 1/2 R1, I would get negative 1/2, 0, and then negative 1/2, which is not good. All right, well, let's look at this. So for number 1, 1, 2, 1, 7, 2, 3, 3, 15, 1, 1, 1, 8. All right, my answers were totally wrong. Oh no. So I have to check the end of that. Example 2. Row echelon form. I'm going to get some 0, 0, 0 there. Oh, that's the trick. Okay, I just swapped those rows. Nice. So actually, I'm fine with that. Third row, I'm just going to swap these two here. So scratch all that here. And it's going to become 1, 2, 3. 0, 1, 1 goes in the middle, and then 0, 0, 0 is that final row. And so this is rank 2. Rank 2 because there's that 0, 0, 0 row. So I need to reduce to row echelon form before I can determine the rank. Got it. Let's go back to example 1, figure out where I went awry. So write out full solution to EX1. I'm going to meanwhile check my work while it's determining that. So I like that I did R3 minus R1, because that should work. And 8 minus 7, that all looks right to me. 0, negative 1, 0, 1. And then I like that I moved that up. Maybe it's the multiply by negative 1. Let's see. Oh, yo. They got the right answer now. So ChatGPT made a mistake at first. I was correct. Sweet. It's annoying that I have to go on. Am I able to go on O1? No, it doesn't let me switch to O1 midway through. So O1 is probably better at some of these things in math, but that's all right. Now let's go to example 3. Construct a 3 by 3 matrix with rank 2. So if it's rank 2, that means I want to have a 0, 0, 0 here. 2 free variables. I need to figure out what free variables are, and infinitely many solutions to the homogeneous system. Okay, so I think I want to make this 0 here for infinitely many solutions. 2 free variables. I think that it's going to be something like, well, let's see. I actually want to look at their answer. What's A, B, and C here? All right, let's go write out a full solution to EX3. So this seems like a different problem than what they told me before, which explains why that answer didn't make any sense. answer this. I'm going to just stop there. Let me actually quote that. Yep, 2 pivot columns, and so the number of free variables five columns. Well, to get 2 free variables, I need to be 5 columns in rank 3 or 4 columns in rank 2. So the number of columns matters a lot with how many free variables there are. So going back to my notes, what I was trying to understand is the difference between free variables versus constrained variables. Explain free variables versus constrained variables with some example problems. So they actually corrected their own problem. We're seeing some jank here from GPT. What I should perhaps do is open another window, go Model O1 Pro, and ask it to do my lessons. Now that I have the lessons drawn out for me here, we'll see how that is as a comparison as a teacher. You see, it's not easy to navigate the world of AI tutoring right now. There's going to be some amazing, robot device you talk into when you're doing work that just answers everything for you and integrates all of this so that the UX is super simple. It's not there yet. It's definitely not there yet. So let's go down here. We're explaining free variables versus constrained variables. So this is a long answer. Oh no, this is the previous one. So pivot variables are locked down by the equations. Others are unconstrained. They can take any value and the system adjusts around them. These are free variables. Free variables are the degrees of freedom in the solution. Pivot variables are determined in terms of the free ones. So let's see here. What I want to do is to put this matrix into row echelon form, find the pivot column, pivot variable. Column with no pivot is a free variable. So, the free variable is when you get 0, 0, 0, I suppose. So here's an example. We have x plus y plus z equals 2, 2x plus 3y plus z equals 5. Write the augmented matrix, do the row reduction. What they did is that so I need to copy this format. They go R2 minus 2R1 becomes R2, and then this thing. That looks neater than what I'm writing. I can start doing that. So, and little side tangent, writing your math down neatly is an underrated skill. I read this article that a Princeton professor once wrote about how he could tell the nationality and background of a student just by where they were from, by looking at their work. The American students, arrows all over the place, really convoluted answers. The Eastern European students or East Asian students, on the other hand, really regimented, organized work. And again, math is about following steps, organization. These things actually really count. So this is why I'm taking attention to improving how I take my notes and show my work on these example problems. So looking at this, we do the row reduction. We've gotten into row echelon form where we have that bottom left 0. We do the back substitution. This is going to be weird. It's y minus z equals 1, x plus y plus z equals 2. This isn't a solvable system that, as far as I can tell, so you have to parameterize it, meaning get something in terms of t. So to do the back substitution, row 2 is, so you take this y minus z equals 1 right here, and you solve for y, so y equals z plus 1, and then you take this first row and solve that x equals 2 minus y minus z. You plug in that z, you get 2 minus z plus 1 minus z, which is 1 minus 2z. So there we have x is 1 minus 2t. We call it t for this free variable. And so the free variable is when you have this solution across a whole line. I want to be able to visualize that, but it's when you use parametric equations to define it in terms of some common variable. So 1 minus 2t for x, t plus 1 for y, and then t is that z variable. Let's see another example. No free variables, unique solution. So yeah, this is a basic system of equations. 2x equals 4, x equals 2. Just simple elimination method there with the plus y and the minus y. Another one, we have 2 free variables. This is going to be crazy here. So now we have 4 variables here. We have x, y, z, and w. And we write the system. We convert to row echelon. It looks like you do R2 minus 2R1. And so you do this for your free variables. You have to have 2 free variables here. So that you need 2 free variables because you can only convert a row to having 2 variables here. Let me see what they said about free variables above, where they corrected the problem. To get 2 free variables, the matrix must have 5 columns and rank 3, or 4 columns and rank 2. I need to get to the level where I can quickly understand what ChatGPT is talking about when they say 5 columns. 5 columns is basically 5 variables. Rank 3 means that there need to be 3 pivot points. 4 columns to rank 2 would do the same thing. So columns minus rank equals free variables. I'm going to write that down because that's something to look into later. So columns minus rank equals free variables. All right. So looking back at these were all rank 2. Let's see if I can understand why these equations were all rank 2. It's because pivot point here. Pivot point here. Pivot point here. So yeah, they all have 2 pivot points. They don't have any 0, 0, 0 rows. The number of variables is different though. So this first one had 1 free variable. The second one had 2 free variables because the columns, aka the variables, minus the rank is equal to the number of free variables. Cool. All right, I'm getting this now. Let's go back to the lesson plan here. Sweet. Mini quiz, end of lesson. Is that where I am? Nice. We're cruising. We are cruising. So which of the following matrices is, here, let's see, 1 second. I was just looking to see if there are any comments. I don't think anyone's watching because I haven't done anything to tell anyone, even friends and family, about this channel. But I realized I didn't have the chat open on OBS. I wonder if Restream consolidates the messages from Twitch, YouTube, and Twitter, or X. That'd be interesting. I want to do some Gauss-Jordan problems also. Give me a quick Gauss-Jordan problem. And I'm going to go back to this. I did the guided examples, and now I have to try the practice problems. Oh, I didn't do this example here. Identify row echelon form and reduced row echelon form. So this is row echelon form. This is row echelon form. This is reduced row echelon form. Yes. Oh, row order wrong doesn't mean that. So it's not row echelon form and it's not reduced. Okay. So the first one was both row echelon form and reduced row echelon form because I had 1, 1 here. Ah, okay. Oh, whoops, I was looking at the wrong thing. Right here. This is reduced row echelon form because it goes ones all the way down. This is just row echelon form, but not reduced because I have this free variable row here. And then this is not row echelon form. I'd have to rearrange these, and then it would be. Let's double check that. Yeah, okay. So I've gotten through the guided examples. I did the problems, I believe. Oh no, I kind of mixed and matched the problems. Yo, I didn't do problem 1. All right, let's go. Problem 1. So I have to solve with Gaussian elimination. I'm just going to go ahead and write the augmented matrix. We have 1, 1, 1, 6, 2, 3, 1, 10, and 1, 2, 3, 13. Let's make my work a lot neater on this one. 13. So the first thing I wanted, so I need to solve with Gaussian elimination. Again, I'm going to get super quick with this by the end of this, but I go draw the matrix. I have first row stays the same. Cool with that. Second row, I need to make that into a 0. So I go R2 minus 2R1. I don't have quite enough space to write it all out, a nice way that GPT did, but this is better. So I do that. It's going to be 2 minus 2 is 0. 3 minus 2 is 1. And 1 minus 2 is negative 1. 10 minus 12 is negative 2. All right. Just erase this here. Cool. Now the bottom row, I'm going to go R3 minus R1. So that's going to make it 0, 1, 2, 13 minus 6 is 7. So I'm close now. I'm going to get it right on this final one here. 1, 1, 1. 0, 1, negative 1. And then this final row is going to be row 3 minus row 2. So it's still going to be 0. This will also be 0. 2 minus negative 1 is 3. 7 minus negative 2 is 9. So now I can solve this. I have 3z equals 9. Z equals 3. I have y minus z equals negative 2. So y minus 3 equals negative 2. So y equals 1. And then finally, x plus 1 plus, I'm just going to sub in these values, negative 2 equals 6. X minus 1 equals 6. X equals 7. The solution is 7, 1, 3. Cool. So I'm going to go now check this answer. Solve and tell me the solution. Scrolling back up so I can check the rest of this here. Row reduce this matrix and identify. Is it in row echelon form or reduced row echelon form? It's in neither because you have the 0, 0, 0, I believe. There's no pivot. Rank is 2. I know that. I already did problem 3 kind of by accident early. Let's go and check this. 2, 1, 3. Cool. So I got everything right except for the x value apparently. Let me just double check my work. So x plus y. Oh, wow. They did a whole darn thing. Oh, is this the Gauss-Jordan? Oh, wow. This was the Gauss-Jordan method. Okay, reduce the augmented matrix to reduce row echelon form, not just REF, so that you can read the solution directly. So this is just an extra layer to all this. So I'm going to rewrite this matrix from where I had it, which was 1, 1, 1, 0, 1, negative 1. And then I'm going to make this last one be 0, 0, 1, and then 3. I divided everything by 3. So that one's already in the Gauss-Jordan form. I need to do something special to the other ones, though. So let's go here. 0, 0, 1, 3. It's annoying to have to write out the whole matrix each time. Maybe there's a shortened way to do that. So what I do for the second row is I'm going to go R2 plus R1. That'll get rid of that third digit here, so it becomes, ooh, oh no, that's not nice. R2 plus R3, on the other hand, money. That's going to make it 0 still, 1 still, and then this is 0. And negative 2 plus 3 is 1. Now for the top row here, make this taller. It's always messy, isn't it? This top row is going to be, why don't I start by going R1 plus R2. This will be 2 steps probably. And when I do that, I get 1, 2, 0. Cool, I like that 0. And then I get 4 right here when I add these up. Then I go to this next one here. 0, 0, 1, 3, 0, 1, 0, 1. And now I want to get this reduced. So I want to get rid of that 2. So I'm going to subtract. I'm going to go R1 minus 2 R2. So it's going to be 1 still. 2 minus 2 is 0. 0. 4 minus that is 2. So there I do get 2, 1, 3. I'm curious why I got this answer before. Was it that I got negative 2 there somehow? No, that was cool. I got 6. Oh, it's literally just because I plugged in the wrong z value. I plugged in negative that. I should have just written it out. This is what I get for skipping steps. Don't skip steps in math. Show your work. All right, 3. Yeah, x equals 2. 2. All right. Messy, but that's all right. So I did a Gauss-Jordan elimination. That's great. Let's see. I wonder how long I've been streaming. We're getting close to an hour here, so I should probably go to the final mini quiz. Eliminate entries below the pivot in column 1. Eliminate below pivot in column 2. Gauss-Jordan. Yep. I did all that. Great. Now I need the mini quiz. So, which of the following matrices are in REF? Rank of this is 3. Oh no, I need to actually solve that, don't I? I got to solve using Gaussian elimination. So I'll go quote, give me the answers for these. I think that the answers neither is in row echelon form. Oh no, maybe the first one is. I'm not sure though. This is. All right. All 0 rows are at the bottom. Cool. This one's not. It needs to be flipped around. Cool. Solve using Gaussian elimination. So I'm just going to write as a note that this is, I don't need it. I can just remember that row echelon form can have 0s on the bottom. I'm assuming a 3x3 matrix always, but that seems to be the standard when you're learning here. So solve by using Gaussian elimination. I haven't done this yet for a 2-variable system. It should be pretty simple though, so I'm going to go right now. MQ, that's the mini quiz, number 2. Scroll down here. So this is just going to look like 1, 2, 5, and 3, 8, 17. So just I need to get this into Gauss form, so I need to make that 3 into a 0. So I'm going to go, this is R2 minus 3R1. So it's going to be second row minus 3 times the first row is going to make that 0. 8 minus 6 is 2. This is 2. Okay, so I have 2y equals 2, y equals 1. And then I have x plus 2y equals 5, x plus 2 equals, x plus 2 equals 5, x equals 3. Boom. All right, that was right. And then finally, the rank of this matrix, all rows are linearly dependent. Each is a multiple of the first. So it's rank 1. When you reduce it, they get fully reduced, everything but that first row. Interesting. Yeah, give me a harder version of this quiz. That would appear in an MIT or Harvard linear algebra early lesson. They give me reduced row echelon form. They want to know the rank of A. That's easy. It's 2, because that bottom row. How many free variables are there in the homogeneous system? So we have these vectors. The vectors I haven't gotten into. I know that's a later lesson, so hold off now. I need to understand what a homogeneous system is too. You know what? The general solution to this is equal to the 0 vector. So is this row echelon form, reduced row echelon form, both or neither? It's interesting because it's 3 by 4. And we got this one here. All right. I'm going to start with Q3 here. Q3. And write this out. 1114. 11114. 23129. And 11226. Great. Now, I need to make my 4s and 9s look distinct. Okay. So I want to get this into row echelon form. So what I'm going to do is go here. 1, 1, 1, 1, 4. I'm going to go, this first one is going to be R2 minus 2R1, 0, 1, negative 1, 0, 1. And then this next one is going to be R3 minus R1, 0, 0, 1, 1, 2. All right, so I've got this into this form. Now what I have here for this last equation is that z plus w equals 2. Now I want to keep in mind, I think that there are 3 pivot variables, or there are 4. I need to see. I know there's 2 free variables and 2 pivot variables. I think that's the answer. So we're going to have to parameterize it twice. So z plus w equals 2. So I'm going to say that w equals 2 minus z. Now I write the next row. I have y. Oh, this is good actually. Y minus z equals 1. So I have now y equals z plus 1. And I'm going to go for the next one then, just separating these. X plus y plus z plus w equals 4. I can substitute out a couple of these. So I'm going to go, let's see how this works. If I say that w equals t and that y equals s, this becomes x. Ooh, I don't have x in terms of this. So let's see, x plus, well, I can do w. Okay, so I got this. I need to rewrite w and y in terms of z first. So I'm just going to do that. So this is x plus z plus 1 plus z plus 2 minus z, which is w, equals 4. So x plus 1 plus 3, 3 plus z minus z is going to be plus z. So then I have x equals z, sorry, x equals 1 minus z. I wonder if my dustbuster got popped right there. A lot of loud noises in this house. Hard to keep things quiet. So x equals 1 minus z. So I have all three variables defined in terms of z. So I think maybe if I just say that z equals t, it'll work. So it becomes a solution of 1 minus t, t plus 1, t, and then w is 2 minus t. I think that's right. So it's actually just one free variable and 3 pivot variables. And then give me answers. The rank of this is 2. Nice. Yep, we got doom doom. Oh, wait. Yep, doom doom. Free variables in the homogeneous system. 4 columns. Pivot columns are 1 and 2. So we have 2 pivot variables. So 3 and 4 are free variables. Okay, that actually makes more sense. So I can just look at it kind of visually up here, that if there's something here, if that these are pivot, oh sorry, these are pivots, these are free, since they have zeros on the bottom. Yo, this is crazy. We haven't gotten to the vector stuff yet, so I don't know how to do this. So to find the general solution, I'm just going to read through this and see if it makes any sense at all. x2 minus 3x3 plus 4x4 equals 0. x2, 3x3 minus 4x4. Wow, this is crazy. So we write a matrix, and you do s times this plus t times that to get the 0 vector. It looks like, yeah, I'm going to have to review that. All right, is this row echelon form? Yes, the pivot moves right, 0 is below each pivot, 0 rows in the bottom. Cool. Reduced row echelon form? No, the pivot in column 1 is not the only non-zero in its column. Yeah, you need 1 and then all zeros. And then solve using Gaussian elimination. Let's hope that I did this right. One free variable, infinitely many solutions. Nice. General solution, -1 plus t, 3 minus t, 2 minus t, t. So it's actually the same as what I got. They just had t as the last variable. I guess that's a more common thing. So let's wrap this up with the same question I always like to ask. Give me a couple challenging conceptual questions from So I did pretty well with our practice quiz. Just need some stuff to review. What I'm going to do is I'm going to record a short explaining my takeaways from each lesson. So Suppose two different matrices have the same reduced row echelon form. What does that tell you about the systems they represent? They're identical systems, right? It's unique for each matrix. The row echelon form is unique, but the reduced row echelon form is. All right. Can a matrix be in row echelon form and still have no solution to the associated system? How? You got to answer these. Answer those conceptual questions. Just answer those. Why do free variables always correspond to non-pivot columns? And why do they represent degrees of freedom in the solution space? Can you express this geometrically and algebraically? Yep, exactly the same solutions. Algebraically and geometrically identical. It's a canonical form, meaning each thing has one. That's a good word, canonical form. I'm going to write that down. Canonical form. All right. And then what if two matrices have the same REF but not the same RREF? Yeah, you can have different row echelon forms. There's a bunch of stuff that could be their other variables, so does not guarantee that. That one makes sense. Can a matrix be in row echelon form and still have no solution to the system? Yes. Can show an inconsistent system. Here's an example. Nice example. So, oh yeah, third, when you have 0, 0, 0 and then a number like 5, that means it's not possible. You get 0 equals 5. Contradiction. Cool. Row echelon form helps us detect inconsistency, reveals contradictory rows. Cool. Free variables. So in reduced row echelon form, a pivot column contains a variable that's solved for explicitly. X3 is in a column not constrained by a pivot. It's not constrained by any equation. You can't solve for it, basically. You can assign any value to it and the system adjusts accordingly. I'm going to look back at that last one I did. I actually liked my choice of having Z as the, right here, having Z as the thing, because we have no zeros in that column. Z is the parameter. Each free variable within its dimension. Cool. All right. So I think that wraps it up for today. Covered a lot of stuff here. Thanks for following. I'm going to be back tomorrow with more, day 3, trucking on through linear algebra. I feel like I've learned a lot already. I was very shaky on row